Hello class, I'm in section 5.7 of the Algebra 2 book, the quadratic formula. We're going to look at example 3. Before we begin, let's look at the quadratic formula. The quadratic formula is used when we cannot factor a trinomial or an equation and we still need to solve. So it helps us solve when we have something that is unfactorable. That's the purpose of it. So when we look at the quadratic formula, we get x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Where do the values a, b, and c come from? The values a, b, and c come from the coefficients in your equation. We're asked to solve x squared minus 10x plus 29, and it equals 0. So if we look at the coefficients in our x terms plus our one constant term, in descending order, they squared to the first power and no variable. We see that we have a coefficient of 1 here. We would call that a equals 1. And we see that we have a coefficient of negative 10 in the b term. B equals negative 10. And we will use the constant term for c, which equals 29. We substitute these values into the quadratic formula, which we just looked at. It would be a great thing to pop down on an index card. So we're going to get x equals negative b, negative 10 plus or minus the square root of b squared. That would be 10 squared minus 4ac. 4 times a is 1 and c is 29. All over 2 times a. 2 times 1. We have our values substituted into the quadratic formula, and now we simplify. So working from here, a negative 10 becomes a positive. It would be a negative 1 times negative 10 in invisible math. So we have 10 plus or minus the square root of 10 squared is 100 minus 4 times 1 is 4 times 29 is 116 all over 2 times 1, which is 2. Okay, I'm going to continue on another slide. I'll rewrite our value at the top. So 10 plus or minus the square root of 100 minus 116 all over 2. We can continue to simplify. 10 plus or minus the square root of a negative number, we've seen that before, all over 2. And we'll continue to simplify. We have 10 plus or minus. So the square root of 16 is 4. And because it's negative under the square root sign, it throws a complex number. We note a complex number with the I term. To let us know we have an imaginary number because we can't have a negative under the square root. So 4i would be equivalent to negative 16 under the square root symbol. We are working with the square root, so we retain the positive and negative as well. And that would all be over 2. We can simplify this because both 10 and 4 divide by 2. 10 divided by 2 is 5 plus or minus. 4 divided by 2 is 2, and we retain the I, the imaginary number, the complex number that it becomes. Remember that a complex number is a compound number, so we're combining two types of numbers here, representing the original negative 16 under the square root that it came from. Right, we're asked to check. Since we have a plus or minus situation, we need to check 5 plus 2i, and we need to check 5 minus 2i by plugging both of those values back into the original problem. So let's look. Starting with 5 plus 2i, we're going to plug that in for x squared for the x, and all of it is squared, minus 10x, so that would be 5 plus 2i for the x, plus 29. Go through and start simplifying across. We're going to have 5 squared plus 2 times 5 times 2i plus 2i squared minus 50 minus 20i plus 29. So this part, this grouping right here, is working to show the original equation that we factored, or would have gotten the 5 plus 2i squared from, and it's in that format that we know is the square of the sum. And of course, negative 10 times 5, negative 10 times 2i is our negative 50 minus 20i plus 29. Simplifying this further, we have 25 from the 5 squared plus 20i minus 4 minus 21 minus 20i all equals 0. So we're addressing like terms and simplifying. If you notice, plus 20i minus 20i goes away. Negative 4 plus a negative 21 is a negative 25, so positive 25 and negative 25 go away, and we do have 0 equals 0 on the check. Okay, so we also check 5 minus 2i squared minus 10, plugging in this x at the 5 minus 2i in the grouping for the x. So 10 times 5 minus 2i, all plus 29. This is the square of a difference. Where did it come from? It came from 5 squared minus 2 times 5 times 2i in the middle plus 2i squared. And we do need our parentheses here, by the way, because if we have I squared, we know that's equal to negative 1. I think we took notes on in class. So do not create a negative 1 with I squared in our imaginary or complex numbers in this situation. And then we're going to have negative 10 times 5 and the distributive property minus 50 plus negative 10 times negative 2i plus 20i plus 29. Simplify further. I'm going to have 25 minus 20i. Rename that grouping here. Minus 4 minus 21 plus 20i equals 0. Okay, when we go through and work this problem, we get, for this part, 2 times 2 and I squared. That's where the negative 4 comes from. Now we're ready to address that. All right, so we have 25, positive 25 is negated by a negative 25, so all of this goes away. Negative 20i is negated by a positive 20i, all of this goes away, and we still have 0 equals 0 for our check. All right, I hope this helps. In checking and solving for the quadratic formula. Also, there will be a velocity problem that we will do on video, and also go over the velocity formula, so pick that up as well in a separate video. And We'll see you soon.